Hello everyone, welcome back to the channel. Today we are solving a really interesting coding problem. Remove duplicates from sorted array second in Java. Sounds simple, right? But there is a twist. We can only keep each unique number at most twice, and we have to modify the array in place. Means we have to use only big O of one extra space. So let's get started. This problem is described as given an integer array nums sorted in non-decreasing order. Remove some duplicates in place such that each unique element appears at most twice. The relative order of the element should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements, after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with big O of one extra memory. Alright, let's break down the problem with an example. In our first example, we have a nums array with elements 1, 1, 1, 2, 2 and 3. The output for this input array will be 5 because we will remove extra 1. It has appeared more than 2 times. Similarly, we keep only 2 occurrences of 2 and retain 3. Collectively, all these elements will be 5, so our output will be 5. In our next example, the elements of array are 0, 0, 1, 1, 1, 1, 2, 3, 3. This time our output will be 7 because we eliminate extra 1 and modify the array without using extra space. Now, how do we solve this efficiently? Can we use two-pointer approach? Yes, we can. We will use a pointer k to track the position where the next valid element should go, and use a loop to iterate over the array and keep track of each element's count. If an element appears at most twice, we store it at nums k and move forward. Otherwise, we skip extra occurrence. This method will offer us a time complexity of big O of n, and it will use big O of one extra space, which is perfect for our problem. Let's break down this code. For that, we will use two-pointer approach. We will initialize first pointer k at index 2, and we will initialize another pointer I using for loop at the same index 2. Now we will check if the value at nums I does not equals to nums k minus 2. For our first iteration, the value for I is 1 and the value at k minus 2 is k is at 2 and minus 2 0. So the value at k minus 2 is also 1. Means these values are equal, means this condition is not satisfied. We will simply reach to the next value of I. Now this time I will point here. Again we will check the value at I is 2 and the value at k minus 2 is 1. This time values are not equal, means this condition is satisfied. Now if this condition is satisfied, then we will update the value at nums k with the value at nums I. The value at nums k is 1. We will update it with the value at nums I, which is 2. So here this 1 will be updated, means changed with 2. So here at the place of 1 it will become 2 and k will be advanced. Now k will reach here. This I will reach here somewhere at this index position 4. Now for this our third iteration, the value at ith index is 2 and the value at k minus 2 index is, the k is at 3 and the value at k minus 2, that is 1, index is 1. So this time both values are not equal. This condition is again satisfied. We will swap, means we will update the value at nums k with nums I. The value at nums k is 2 and the value at nums I is 2. Now this 2 will be updated with this value. So this 2 will come here and k will reach this position. I will reach this position. Again we will see for our fourth iteration the value of I is 3 and the value of k minus 2 is 2. Both the values are different, so we will update the value at nums k, which is 2 this time, with the value at nums I, which is 3. So the value here will be updated with this value. So this 3 will come here and the k will be advanced, I will also be advanced. The array has finished. For loop will stop here and finally we will get the array as 1 1 2 2 3 and an extra free space in last. This is how we can use this code in our problem. And that's it for today's video. We learned how to remove extra duplicates in place using big O of n time and two pointer approach. If you found this helpful, drop a like, subscribe and let me know in the comments what problem you want me to cover next. See you in the next one. Happy coding!